Hello. Today, in this video lecture, we will see limitations of Euler's formula. We had seen that crippling stress equation in our previous lecture, that crippling stress is nothing but the sigma CR is equal to pi square E upon L upon K square. That means pi square E upon lambda square. Pi square E is modulus of elasticity and lambda is slenderness ratio. And this L is effective length and this K is disk radius of gyration. So first understand this equation. See here wording. The critical stress is directly proportional to the modulus of elasticity of material. See here. See, critical stress is directly proportional to modulus of elasticity of material, and it is inversely proportional to the square of slenderness of column. See here. This is inversely proportional because this is lambda is in denominator. So critical stress is directly proportional to modulus of elasticity. Meaning of that is, if modulus of elasticity increases, that means critical stress is also proportionally increases. And slenderness ratio is inversely proportional. That means if slenderness ratio is increases, that means critical stress is proportionally decreases. Inverse relation between both of these. So see this, first read. When the slenderness ratio decreases, the critical stress increases. That we saw. When the slenderness ratio decreases, critical stress is increases, because relationship between them is inversely proportional relationship. See here also, in this graph also, that is seen as C. If the slenderness ratio is decreases like this, C, from here to here it is decreases, and see here, this is, first understand that graph. C, on x-axis it is slenderness ratio, lambda is equal to L upon K, effective length upon least radius of gyration, and on y-axis it is critical stress, sigma CR. And understand that sentence meaning, that C, if slenderness ratio is decreases, that critical stress is increases. See here, slenderness ratio is minimum but critical stress is here maximum. So this is meaning of that sentence. Through graph I explain you. Next is the value of L upon K. L upon K, that means lambda, and lambda is slenderness ratio. The value of slenderness ratio at the point C is called as critical value of slenderness ratio. So why this is called as critical value of slenderness ratio? Because C, at point C, at this point, before this point C, this is short column, and like after this point C, this is long column. That's why this C point is critical value. Now see this point, for any slenderness ratio above this value, that means greater than this value, greater than this C value, C slenderness ratio value, that means see there they are written as 80, that means greater than 80, the column fails by buckling. Why buckling? Because this is long column. And for any value slenderness ratio less than this value, that means less than this C point and less than this 80, this column fails by crushing. Because this is short column. So understand this through graph. See this graph, that is a strength limit, very short column, the slenderness ratio, and the critical stress is very higher at a lower slenderness ratio, and slightly slenderness ratio gradually increasing, and this critical stress gradually decreasing as inelastic stability limit, proportional stress limit, Euler's curve. Like see, Euler's curve is only applicable for long column, and this is in the long column region only. And for short column region, see here inelastic stability limit. So understand that. Now next is Euler's formula is not applicable for short column. Yes, that I told you. And this is the limitation of Euler's formula. Yes. Mathematically, Euler's formula is applicable if crushing stress is greater than equal to buckling stress. See, Euler's formula is not applicable to short column, it is applicable to only long column, and we all know that long column is only filled by buckling. That's why this Euler formula is applicable for crushing stress is greater than equal to buckling stress. Remember this is very important. Whenever this crushing stress is greater than equal to buckling stress, that means Euler's formula is applicable. Crushing stress, see why this is written as, understand that science behind that equation. Like, assume that this is column and this crushing stress is assumed at sigma CR is okay. Here something crushing stress. Stress is nothing but the load upon area. So here it is load. So this crushing stress is greater. That means this column is not failed by crushing. And buckling stress is minimum, that means it is failed by buckling. Failed by buckling, that means this is long column. That's why they are written as Euler's formula is applicable only for if this is true, if this is like obeys. Crushing stress is greater than equal to buckling stress, and crushing stress they denote this as sigma CR, and buckling stress like we had calculated it, buckling stress in terms of slenderness, so pi square E upon LE upon K square. So rearrange it mathematically, pi square E square this side and pi, this sigma CR denominator to right hand side. Then again, like just play with some mathematics. LE upon K sigma CR is equal to under root of pi square E upon sigma CR. So this is like our outcome. What this equation tell us that when slenderness ratio is greater than pi square E upon sigma CR, the Euler's formula is applicable. This is Euler's limitation. When this slenderness ratio is greater than equal to this pi square E upon sigma CR, then only Euler's formula is applicable. Remember this. This is very important. Now next we will see example. See this example. Maximum value of slenderness ratio for mild steel column. So we will find maximum value of slenderness ratio for mild steel column. So crushing stress for mild steel column, they had given us that sigma C is equal to 330 MPa, and they had given us crushing stress. They didn't given us that buckling stress. Understand that. The sigma CR is crushing stress. Crushing stress. Young's modulus of mild steel like 2.1 into 10 raised to 5 MPa, and just use that equation that we saw earlier, that sigma clearly upon effective length upon least radius of gyration greater than equal to under root of pi square E upon crushing stress. So just put that values, pi square into 2.1 into 10 raised to 5 upon 330, that slenderness ratio comes 80. So when slenderness ratio for mild steel is less than 80, then only that then Euler's formula is not applicable. See that slenderness ratio is greater than equal to 80, then only Euler's formula is applicable. If this is less than 80, then Euler's formula is not applicable. So this is very important, like understand this. Now next again one different numerical, slenderness ratio for long column with fixed end. So that numerical is determine the slenderness ratio at which the Euler's formula for a fixed end can be used. they had given us that E is equal to 200 GPa, and proportional limit, that crushing stress they had given 250 MPa. So just push that E and crushing stress, you will get that slenderness ratio as 88.86. So that is limit for that slenderness ratio. So that slenderness ratio should be greater than equal to 88.86. Then only Euler's formula is applicable. So this is the slenderness ratio at which Euler's formula is applicable. So this way those topics are completed. Just go through the topics again. Limitations of Euler's formula. This is crippling stress equation, pi square E upon lambda square. Again we saw that figure. Again see how this equation comes. This equation comes by, we know that this pi square E upon LE upon K square, this term we know that, and this is new for us, that crushing stress is greater than equal to buckling stress, then only Euler's formula is applicable. Remember that crushing stress is greater than equal to buckling stress. Okay, that means buckling stress of that column should be minimum. So in other sense, that column should be fed by buckling, so that's why they are like given that equation like that. So just we go through some mathematics and we would get that equation. LE upon K greater than equal to pi square E under root of pi square E upon sigma CR. LE is effective length, K is least radius of gyration, and this is nothing but slenderness ratio, and this pi square is constant, E is modulus of elasticity, and sigma CR is crushing strength. So now we know that there is limit for slenderness ratio, like in Euler's theory, that slenderness ratio should be within that range, should be greater than, like that, should be greater than this value. When slenderness ratio for mild steel is less than, should be greater than this value. This is limitations. And how this value comes? By these two, by some mathematics. See, by this equation with the help of crushing stress equal to buckling stress. So thank you very much